This is our table, right? This is joint A, joint B, and joint C. This is span AB, span BA, span BC, and CB. Meaning that what this means is that, given this question, we have two span, which are what? Span AB and span BC. This is it. This is AB. This is AB, and this is what? BC. Right? For AB, I have two joints. For AB, I have two joints. And what are these joints? A and B. So we are denoting A as AB, and we are denoting B as what? BA. Similarly, for span BC, I have two joints, right? I'm denoting B as BC, and I'm denoting C as what? CB. Now, go back to what we've solved. Check. What are these distribution factors that we've calculated for each span?
AB, so right here.
AB, is it AB or BA? BA. It is what? BA. Distribution factor. This is it. It's actually BA. I'll answer that. It is so because when you are in this beam, at point B, how do you calculate your stiffness factor? He said from B back to A, right? Then from B back to C. So meaning if you are representing your distribution factor, it is your distribution factor from B with respect to A. Similarly, from B with respect to C. Now, check. This distribution value that we've calculated, what are these values? Check. What are these values? Do you have any distribution factor for AB? For AB? No. Distribution factor, do you have for AB? No. What about BA? And what is this value? So substitute 2 over 3. For span BC, what is the distribution factor? Substitute. What is the distribution factor for CB? There's no distribution factor. So moving on, substitute your fixed end moment. Now go back to joint A. What's your fixed end moment? What's your fixed end moment? Minus 13.33. For this joint B of span AB, what's your fixed end moment? Positive 13.33. For span BC of joint B, what's your fixed end moment? Minus 11.25. For span BC of joint C, what's your fixed end moment? Plus 11.25. Plus 11.25. Now, up to this level, the idea is that from this beam, initially, if you read that question, the question says that calculate the value of moment at what each support. At each support. Meaning, there's a moment, you can get the value of moment here, right? You can also get the value of moment here. But the value of moment here will be what? 0. The value of moment will be equal to what? 0. You can relate this to shear force and bending moment. When we did shear force and bending moments, we said, given a semi-supported beam, your bending moment starts with what? 0, and your bending moment what? End with what? 0. Your bending moment starts with 0, and your bending moment ends with 0. The question is why? Why is my bending moment starting with 0, and why is it ending with 0? I guess what I'm saying. Why is my bending moment starting with 0, and why is it ending with 0? It is starting with 0 because at point A, I have a pinch support. I guess what I'm saying. At point A, I have a pinch support, and at point B, which is the last end, I also have a what? Pinch support. Now, let me illustrate what I'm saying. Say you are given a semi-supported beam. Call this A, call this B, call this P kilonewton. From here, let's draw the bending moment diagram of this beam. Let's draw the bending moment diagram of this beam. What's the idea? Bending moment starts with what? 0. Bending moment ends with what? 0. And at this midpoint, bending moment will be what? Maximum. Meaning, let's say our bending moment is here. Then you have this, right? Right? Now, same idea here. Since I'm having this type of support, it means at this point, bending moment value will be what? 0. Bending moment value will be what? 0. Now, under moment distribution method, since you already know that At this point, bending moment value will be what? 0. You are going to release. You are going to what? Release. What's the idea behind release? You are using the opposite sign of the movement. You are using what? The opposite sign of the movement. Now, go back to where you are going to have your bending moment equals 0. At what joint are you going to have your bending moment equals 0? At joint C. At joint C, you have your bending moment value equals to what? 0. Now, at that joint, you are going to release. You are going to what? Release. The question is, what is the idea behind release? Identify. What is the fixed end moment at that joint? What is the fixed end moment at that joint? Plus 11.25. Now, when releasing, you are using the opposite sign of the fixed end moment. The opposite sign becomes what? Minus. Minus. Now, the idea is the positive 11.25 minus 11.25. It becomes what? 0. And that's it. Meaning, the 0 value for this moment, which you occur here, that's how you work it out. Any question? That's how you work it out. Now, right. Release C. Release what? C. You know how to release, right? Meaning for joint C, I have what? Positive. I have negative 11.25. Negative 11.25. From here, the next step is what? Carry over. From here, let's get our value. Okay, from here, the next step is what? It is called carry over. You are carrying over what you've released. This guy, just now, generally, when you want to carry over a particular value, just divide by 2. Divide by what? 2. Meaning, you are carrying over this guy up to this joint. Now, when carrying over, you are maintaining your span. You know, this is span AB, this is span BC. This is what? Span AB, and this is what? Span BC. Now, you want to carry over this guy. Am I coming to this span? Or I've seen, okay, call this span 1, call this span 2. Carrying over this guy. Am I still in span 1 or span 2? The idea is that when you are carrying over, you are still at that span. You know, this is span AB and this is span BC, right? Now, I want to carry over this guy. My question is, do you know this span BC as 1? Do you know this span AB as 2? This carrying over that I'll be getting, am I still at span 1 or span 2? Span 1. What it means is that when you are carrying over, you are still maintaining that span. Now, when it comes to carrying over, just divide the value by 2. Just what? Divide the value by 2. By the time you divide the value by 2, what do you have? Divide this value by 2. Negative. By the time you divide by 2, you have negative 5.625. Negative 5.265. Now, let's find the initial moment. Let's find the initial moment. Initial moment. Let's find the initial moment. How it works is that from your fixed end moment, sum the value up. From this fixed end moment to your carry over. You want to get your initial moment now. How do you get your initial moment? Starting from your fixed end moment up to this carryover, sum up all the value. Sum up all the value. For this first one, what do you have? Minus 13.33. For this one, what do you have? Positive 13.33. For this one, what's my answer? What's my answer to this? 16 minus 16.875. Then this is what? This is what? 0. And from this beam, we know that the value of C here is what? 0. We know that the value of C here is what? 0. So that's the idea behind this. 0. Now, next step. From here, distribute. This and this, you give me minus 16.875. From here, the next step is what? Distribute. When it comes to distribution, the idea is very simple. You are distributing your excess moment. You are distributing your what? Excess moment. You are distributing your excess moment. Now, take note. Your excess moments occur at the intermediate support. I said from here, distribute, right? Distribute. You want to distribute. How do you distribute? You are distributing your what? Excess moment. I am distributing my what? Excess moment. Now, at what joint do I have excess moment? At the intermediate support. When we say intermediate support, meaning the support you have at the midspan of your beam. Now check, where is this support located? B. Meaning my excess moment occur at joint B. Trace joint B down. What are these values that I'm having at joint B? We have two values, which are what? 13.33 and negative 16.875. Now, when we say excess moment, moment, and even from here, I'm having 13.33, and in this place, so I'm also having negative 13.33. What will my answer be? 0. I want to explain the idea behind excess moment. Instead of this 16.875, let's say I have positive 13.33 and I have negative 13.33. In this case, no excess moment. Why? Because 13.33 minus 13.33 is still what? 0. Meaning up to this level, you are going to stop. Up to this level, you are going to stop. Meaning any answer you have from here, that becomes the value of the moment at each support. But in this case, when you subtract, what's the answer? Subtract this, what's the answer? Excess moment, that's positive 13.33 minus 16.875, and this is equals to what? 0.545. Our excess moment. Hello, do you know how we got this excess moment? Do you know how we got excess moment? We got the excess moment from this. I said excess moment occurs what point? At the intermediate support. When you have your intermediate support and you have your intermediate support at B, meaning excess moment will occur at what? B. Right? Now from here, come back to this table. At point B, what are these values that you have at point B? Plus 13.33 and negative 16.87. Now subtract, you get this. Meaning negative 13.545. Negative 3.545. This becomes your what? Excess moment. What do you want to do with this excess moment? You want to distribute with this excess moment. You want to what? Distribute with this excess moment. But if you are distributing now, you are using the opposite sign of your excess moment. You are using the what? Opposite sign of your excess moment. Meaning, if this is my excess moment, I'll be distributing with the what? Opposite sign. The opposite sign becomes what? Positive 3.545. So I'm distributing with this value. Distributing with this value multiplied by the distribution factor. I'm distributing with this value multiplied by the what? Distribution factor for span BA. I'm distributing with this value multiplied by the distribution factor of span BC. Now write distribute. Distribute. We are distributing. To get the distribution at this span, which is span BA, meaning identify what is your distribution factor at BA. What is your distribution factor? Meaning 2/3 multiplied by the excess moment. What is the excess moment? 3.545. I am distributing with the opposite sign of my excess moment. This is for BA. Similarly, for BC, identify what is your distribution factor? 1/3 multiplied by what? 3.545. Now, input this in your calculator. What's the answer? Positive 2.36, right? The second one is what? Positive 1 point. Please, let's confirm. Positive 1 point. Positive 1.8. Positive 1.82. I'm having positive 1.82 now. Substitute. Meaning for span BA, My distribution will be what? What will I substitute here? From here, BA, I'm distributing BA, but that will be what? Plus 2.36. For this BC, that will be what? Plus 1.82. Now, up to this level now, I want to say something now. If to show that you are following me, now I want to carry over. You know that if I'm carrying over, I'm still at that particular span. You know, I can carry over at this span. Let's say this span is 1. Let's say this span is 2. I can carry over at this span 1. I can also carry over at this what? Span 2. Right? Are you following me? I can carry over at this span 1. I can also carry over at this what? Span 2. Now, let's go back to the initial carryover we did. When we carry over, we just indicated this arrow saying we divided by 2 and we wrote the answer here, right? Now, let's say we are carrying over using this value. Let's say you are carrying over using this value, meaning I'm going to have my cross like this. Let's say you are carrying over using this value, I'm going to have it like this. But the question is, carry over this guy, what will your answer be? This one is correct. 0 point. This one is what? This one is what? 1.18. Positive 1.18. Positive 1.18. Now, I want to say something. You know, in this place, I just want to ask this question. From what I've explained earlier, I said movement at this point will be what? 0. Movement at this point will be what? 0. Now, me carrying over another value here, is it proper? No. Because you already know that the value of movement here will be what? 0. So no need of be carrying over your what you distributed. Are you getting my point? You are not releasing anything. Are you getting me? Meaning there's no need of you carrying over the value that you distributed, since you know that this answer will still be 0. Up to this level, you'll be having 0 point something, which you can still approximate as 1. Which is wrong. It is wrong. Why? Because the value of movement must be 0 and not 1 or 0 point anything. Meaning this place, you don't have you are not carrying over. You are not carrying over. Do you get my point? Meaning if you are carrying over, you are only carrying over at what? Span AB. So right, carry over. Now take the final moment. Take the final moment. Taking your final moment, sum all this value up. Sum all this value up. From the initial moment, from this initial moment up to this carryover, sum all your value up. What do you have? Tell me the value at each joint. From this initial moment up to this carryover, tell me the value at each joint. That's what? For this first one, what's the value? Negative. Is it minus 12? Yeah. Minus 12.15. Now solve this. What do you have? 15.69. Positive 15.69. For this joint, what do you have? Negative 15.05. Then for this, what do you have? 0. Now, up to this level, we are going to distribute again. From here, hello, to back up what I said earlier, I said you won't distribute only if the value at your intermediate support they are equal, meaning you be having 0 there. You won't distribute only if the value at your intermediate support they are equal to 0. Now check. I've got to my final moment. Now up to this final moment, distribute. You will distribute only if you have another excess moment. But if you don't have any excess moment, you will distribute again. And you know how to identify your excess moment. Your excess moment occurs the joints where you have your intermediate support. Where you have the point where you have your intermediate support. Right? Now this is point B. At point B, you have intermediate support. Now, using this fixed end moment, what the value at joint B? There is 0. Why? How do you get 0? 15.69 minus 15.693, which is what? 0. Meaning up to this level, this is your final answer. This is your final answer because the value of moment at B is what? 0. Compared to what we did initially, from this place, I'm having what? Negative 3.545. So excess moment. That's why I have to what? Distribute. That's why I have to what? Distribute. Meaning that, hello, meaning that for this beam, I've calculated the fixed, I've calculated the moment at each support. I've calculated the moment at each support. Now substitute. What's the moment at point A from our table? Minus 12.5. What's the value? Minus 12.15. What's the value at point B? It will be negative 15.693. Then for C, it is what? 0. Now, do you know why it is negative? Do you know why I choose negative? I'm choosing negative because when I explained, when we started this class, I said you are going to have two bending moments, right? The first one is due to vertical loading, while the second one is what? Due to the what? Support. Now, take note. The moment due to your support, the bending moment value, it is always negative in nature. It is negative in nature. I guess what I'm saying. Don't worry, by the time you draw the bending moment diagram, you see what I'm saying. It is always negative in nature. So for this, you observe something. For this A, I'm having a negative answer, negative 12.15. For B, will I be choosing negative or 50? Will I be choosing the positive or the negative? I'm choosing negative. Why am I choosing negative? Because the movement due to the support is always negative in nature. It's always negative in nature. Is that the vertical loading, they are positive in nature, while the vertical loadings, they are positive in nature, while the support one, they are negative in nature. So you are bringing negative and positive together, and that will give you your bending moment diagram of this beam. From here, now let's draw our bending moment diagram. Drawing your bending moment diagram, you are going to relate this with what I've explained before. I said, given a fixed beam, you have to bending moment diagram. You have to bending moment diagram. The first one is what? Due to your vertical loading, while the second one is what? Due to your support. Due to the movement and your support. Now, same idea. For your beam, let's draw the bending moment diagram due to the vertical loading. Bending moment diagram. Bending moment diagram due to vertical loading. Or you say vertical load. Now, due to vertical load, for span AB, identify what type of load am I having. I'm having a UDL. I'm having a UDL. And for a UDL, let's say this is your beam. Say this is a UDL. And say this is your point load. You know, my bending moment will be in this manner, right? Then for this point load, my bending moment will be of this nature, right? Similarly, that's what I'm also doing here. But what we are taught in class is that structurally, this bending moment that is opposite is going to what? Come down. We are inverting it. Coming down is still taking positive. Coming down is still taking positive. It does not affect the sign, be it positive or negative. And normally, what I should have done here is me having my vertical loading, my movement due to the vertical loading in this manner and in this manner. But what we have been taught in class is that it is the opposite. So now, drawing the bending moment of this UDF, I have this, right? I have this. This is what? Positive. What is the value? Now, go back to span AB. What is the value of the vertical loading due to at span AB? What is the value we got? 20, meaning that this is this UDL, the intensity is what? From here to this place is what? 20 kilonewton meter. Check for your single supported beam. What's the intensity?
22.5.
You know, if this is 20, then 22.5 will be greater than this. Meaning you have 22.5 like this, right? This is 22.5 kilonewton meter. This is bending moment due to what? Vertical loading. Now let's draw bending moment due to what? The moment at each support. Drawing bending moment due to the moment at each support. This is what I have. Now from here, at point A, what's the value of your movement? This is positive, this is positive. At point A, what's the value of your movement? Minus 12.15. Minus 12.15. So let's say let's say this is 0. Let's say this is the origin 0. Let's indicate minus 12.15 here. Minus 12.15 for what? A. On B, what's the value of bending moment?
Minus 15.6.
Minus 15. If this is minus 12.5, then minus 15 point, what do you call it? Let's say minus 15.69 is here. 15.69. Then for this C, what's the value of movement? 0. Now, join this line. So this is what we have. We have this. Any question? And this is always negative. The nature of your bending moment due to the support reaction is always negative. While for your vertical loading is always what? Positive. Is always positive. Now, you are going to bring these two together. You are going to bring the vertical loading and your moment loading. To now finalize your answer, bring the positive and negative, bring it together. So let's bring the positive and negative together. This is what we have. This will be 20, right? And this is what? This is 20. This is what? 22.5. Now, I want to join negative 12.5. If from here to here is 20, let's say negative 12.5 is somewhere here. Do you agree with me? So let's say this is 12.5. Then for B, what's the value here? 15.69. You know, this is 20. 15.69 will be somewhere here. So let's say this is 15. Let's say this is 15.69. Then lastly, what's the value here? 0. Now join this line together. Join this line together. This is what you have. Join this line together. 12.5 to 15.69, then towards 0. 12.5, 15.69, then lastly 0. 12.15 towards 15.69, then lastly towards 0. But you know, you said this is positive, this is negative. So indicate your positive and negative. This is your this is positive, right? This is positive, this is negative, and this is negative. Any question? Any question? This is positive, this is positive, this is negative, and this is negative. Now, right, this is your final bending moment diagram. I am done with that question. But if the question now proceed and says that calculate. If the question now proceed and says that draw shear force diagram, you are going to solve again. So that's it. Alright, this is how you solve question having this type of support. Given any type of beam, which is statically indeterminate beam, having any type of support like this, given any type of beam, which is statically indeterminate beam, having this type of support, this becomes the step from step 1 up to the last step. This table will not change. The same process you undergo, the same way you solve this table for this type of support. Say you are given another beam of this type of support, loaded with another load. Let's say the load now, all through, you are having a UDL. When we just finish solving and this new question, what is the difference? The loading, right? The loading is different. Meaning that's the difference between what we just solved and this question. So what I'm trying to say is that this table, the same way you computed the value of this table, it will not change. It will not change. Why? Because you have the support the same. The support is the same. But what if you have a support? Let's say you have your fixed support. This place is fixed support. This place is fixed support. This table, the way you are going to solve this table, it will change. It will be different. So what this means is that generally, given any type of continuous beam, per se, let's say statically indeterminate beam of different type of support, the way you analyze the table, the way you compute the value of the table is different. Is different. So that's how it works. It's different. All right. This comes to the end of this video. This comes to the end of this video. In our next video, we will solve more questions, solving for the shear force and the bending moment diagram.